Okay, so we'll close this problem here, and people did real well on it. Okay. First of all, square root of 25a can be written square root of 25 times the square root of a. Not everybody follows the same procedure. A lot of people went to the factorizations and stuff, and that's really good. Okay, so I'm just kind of cutting through that. Doesn't mean that you shouldn't write it out that way, but since people are getting the right stuff here, we're just going to go this way. Okay, so that separates out in this. Now the square root of 75. Go right like this. Okay. And the reason I'm going to write it like this is every one of these terms has a square root of a on it, doesn't it? Okay. Now I've got a perfect square here, and the biggest possible perfect square here. So you prime factor this, you get 5 times 5 times 3, right? And that's of course 25 times 3. And you end up with 5 square root of a plus 10 square root of a plus 5 times the square root of 3 times the square root of a. And I write it this way because now I can factor out that square root of a. I can write this as 5 plus 10 plus 5 square root of 3 times the square root of a. And Bertie's asking to be admitted, so she's with us. Hello, Bertie. She probably can't hear me yet. Now I can't see my own screen. I don't know why Zoom does this, but there we go. Okay, Bertie, I assume you're here, and I was just thinking about you when we were doing this. I thought this is something you probably want to see. So we're going to do it again. Yeah, this, and this. Okay, there's a problem. We want to simplify this. And it's very easy to see that we can simplify by doing the square root of 25 times the square root of a here, square root of 100 square root of a. And here it'll be square root of 25 times the square root of 3 times the square root of a. And I do it this way. I don't do the 3a under the square root. That's going to give us the advantage that when I do the next step, taking the square roots of 25, 100, and 25, every term has a square root of a on it. So I can factor out that square root of a, and I can write the sum like this. And then I can write like this. Okay, I can just add the 5 and the 10. And then the 5 square root of 3 is sort of an unlike term. Not really an unlike term, but with the square root of 3 there, I have to write it like this. I don't want to say any more about it. That's pretty obvious. Okay, so that works out pretty well. Now, let's do another one. Let's do a square root of 98a b squared c cubed. Now, plus the square root of 147 a squared b squared c. So, can I ask everybody to work on that for a minute? Let's take a look at that. most of you are doing pretty well here. Square root of 98 reduces to the square root of 7 times 7 times 2. And now it's going to be, I'm going to write it this way. We're going to have A, we're going to have B squared. What are we going to do with C cubed? I want to write that as C squared. I'll write it as C times C squared. Anticipating the idea, when I take the square root of C squared, I'm going to get a C outside the radical sign, right? And then here, better 47 is 7 times 7 times 3. And then that's going to be times A squared, B squared C. And I don't have to do anything with the exponents here because they're all even exponents. So I'll always be able to do the square root. Now over here, since we had a C cubed, that's like a C squared, but then there's another C, right? So that's gonna work. So, now I can write this one as square root of 7 times 7. Square root of B squared, square root of C squared. I can break it up like this. I will put the numbers out separate from the symbols. Just like we did up here. And then we're going to have this here. It's all pretty straightforward, okay? Now let's just here. That's going to be then square root of 7 times 7 is 7. Square root of B squared is B, square root of C squared is C. If we assume that B and C and A are all positive, okay, B could be negative, then square root of B squared could be the negative of B. But I'm not going to worry about that right now. Okay, so we get a 7BC here. And then we have a square root of 2 times square root of AB. Over here, we have 7 square root of 3 A, B times square root of C. So we have square root of 2 to 7. There. I'll have this, and then I'll have a 7 square root of 3. Plus AB times square root of C. Now I can do a little more factoring than just this, but I'm not going to. I'm just going to factor out the 7. can visually do this. It's kind of a mess. It doesn't simplify a whole lot more. Now you could factor out the square root of AB and you'd end up here with the square root of AB and stuff like that, and factor out the square root of C. But there's not much point in doing that. So I said that's about as far as it goes. Okay, so y'all did pretty well with that. But yeah, it's maybe a little confusing about what you want to end up with. The problems that you get in the open math, they're not going to be quite, I won't say quite as complicated, because it isn't really all that complicated, but they're going to probably work out nice. Okay? Work out more nicely for us, see that later. Make sense? Yeah. No, hang on a minute. Okay. Thanks to the individual who caught my error here. I had AB here. Of course, all the B's have been taken care of here. It's AC, right? I wrote that down carelessly. Let's correct that. So AC, AC, AC. Thanks. Good eye. Okay. So there we have it. Okay. Okay. People in pretty good shape with this. I'm going to talk about rationalizing the denominator. I have an expression like 8 divided by the square root of 3. Okay. A standard form for an expression like this would not have a square root in the denominator. We wouldn't have a radical in the denominator. Okay to have a radical in the numerator, but not in the denominator. Now, historically, that's because the square root, if you're going to approximate it accurately, is going to have several significant figures. Might be 5 digits long. And dividing by a number 5 digits long using long division is a royal pain. It's easier to multiply by a 5-digit number than it is to divide by one if you're using the division algorithm. And back, when I was in school, we had to chisel our math into the cave walls. Okay. And when we filled it up, we had to move to another cave, and there wasn't always another cave. So we had to keep things as compact as possible. Okay. So we got in the habit of not wanting square roots in the denominator. A little harder to do the mental arithmetic with square roots in the denominator. Not really. Mental arithmetic is limited anyhow. We got good at mental arithmetic also, trying to preserve the cave walls. Okay. It got expensive. Then we'd have to wait thousands of years for erosion. Future generations. Okay, well, anyhow, 8 over the square root of 3. We would have to agree that is equal to 8 over the square root of 3 times the square root of 3 over the square root of 3. Because square root of 3 over the square root of 3 is just 1. So multiplying by this doesn't change the value of the expression. Well, then that's 8 square root of 3. So the square root of 3 squared, and the square root of 3 squared is just 3. Does that make sense? Okay, well, let's try another one. Let's try this. Go ahead and work it, and then see how you're doing. Okay. Did real well with this. Let's just go over it. This looks a little weirder than just an 8 over square root of 3, right? We got that square root in the numerator, but it makes no difference in what we do. We're trying to, we call it rationalizing the denominator, expressing this as a fraction with an integer denominator, okay? So, multiply by the square root of 7 over the square root of 7. And writing out all the steps, just to remind ourselves of all the details. Write this. And then this could be 15 times the square root of 14 over 7. Okay. Now, if you left the square root of 2, square root of 7 there, now you really want to go ahead and now combine these. They're both numbers, just combine them into one square root. But that's a fairly simple process. Okay. How about this? See what you can do with that. Okay. People kind of stuck at this point, but I'll get you unstuck. I can write this as a square root of 17 over the square root of 6. And now it should be obvious what you do. If it isn't, I'll help you along, but I'm pretty optimistic everybody's going to get that. Okay, the only tricky thing about something like this is you got to remember that that's the square root of 17 over the square root of 6. Once you do, you see that, well, what we're going to do then is we're going to multiply by square root of 6 over the square root of 6. We don't worry about what's in the numerator at all. We're only focused on the denominator and getting the denominator, getting the fraction or the expression into the form where the denominator is a whole number. Okay, so we do that by the same trick we use up here. Okay, well, 17 times 6 is 60 plus 42. Improve that to 102. By the way, 17 is 3 less than 20. 6 times 20 is 120. 3 times 6 is 18. 120 minus 18 is 102. Just checking it 2 ways. Here's my brain misfire. Okay. It's a good habit to check things 2 ways. Okay. So here we have it. Now here's another one. This is a little. I'm probably going to have to show you one. I'm going to assume I have to show you. I don't know if I do or not. Let's say we got 15 over 2 minus the square root of 5. Now again, we've got a radical in the denominator, and we don't want that. We get this thing into a standard form. So what are we going to do? I'm going to multiply this by 2 plus the square root of 5. Over 2 plus the square root of 5. Giving us 15 times 2 plus the square root of 5 divided by 2 minus the square root of 5 times 2 plus square root of 5. Now go ahead and use the distributive law on both the numerator and denominator and see how this works out. Okay. Now, people did pretty well with this, but missed a couple of really obvious things. So we want to make sure we point them out. Okay. And the pattern's always going to be the same. So once you understand it, it's okay. Now I said multiply numerator and denominator out using distributive law. Most people concentrated on the denominator and didn't do the numerator. Okay. But I'm going to go ahead and do the numerator. That's easy. This will be 30 plus 15 square root of 5, and that should be pretty obvious. Okay. Make sure this board is moved over enough. Yeah. Here's the problem. I'm going to move it over because I'm writing down here in the watermark could get away on the recording. Okay, so we multiply the denominator out, and everybody multiplies the denominator. Well, I'm not sure. But when you multiply the denominator out, 2 times 2 is 4. And 2 times the square root of 5 is the square root of 5. There's 2 times the square root of 5. All right, we'll write it up for it. That's 4. Plus 2 square root of 5, 2 times 2, and 2 times 5. Then you have negative 2 times square root of 5. You have negative square root of 5 times 2, so that's going to be negative 2 square root of 5 plus square root of 5 times square root of 5, right? Well, that's going to be 30 plus 15. Square root of 5. And have a plus, this is minus square root of 5 times square root of 5, right? Okay. 2 square root of 5 minus 2 square root of 5 is 0, right? Subtracting something from itself. So that goes away. And then you have 4 minus the square root of 5 times the square root of 5, right? Now that'd be 4 minus the square root of 25 if you wanted. But just knowing what a square root is, you should understand that square root of 5 times the square root of 5 is 5. Square root of a number is a number you multiply by itself to get that number, okay? So you're going to get 4 minus 5. And I need another step. Actually, maybe 2 more steps. I'm just going to put down etc. Okay. The point is, if you have some number plus or minus the square root of another number, you can multiply by 2 minus or plus square root of that number, and everything works out real nice when you get a whole number. So Let's just look at that process a little more carefully. What's a minus b times a plus b? It's a times a plus b minus b times a plus b. Now we did this when we were doing factoring, but I didn't stress it a whole lot. Okay, so then we have a squared, a times a, and ab, a times b, and then minus b times a, which is the same as minus a times b, minus b squared. That comes out a squared minus b squared. Always. Now, if b is the square root of some number, then b squared is going to be that number, right? So if b is the square root of 5, then b squared is going to be 5. So it's always going to work. So let's do another example. Let's say you have simple one, 4 over the 7 plus the square root of 2. See if you can work that out. Okay, rationalize this. We'll multiply by numerator and denominator by 7 minus the square root of 2. And we get this. And the numerator multiplies out in the obvious fashion. And then we get 7 squared minus 7 square root of 2 plus 7 square root of 2 minus square root of 2 times the square root of 2. It's distributed off. That's going to give you 28 minus 4 square root of 2 divided by 7 squared is 49. Negative 7 square root of 2 and plus 7 square root of 2 is 0. And then we have minus 2. So I'll leave that much of the board for you to do this. All right. So the word square root 7 square root of 4. And there we have it. Okay. Should be well prepared for the next homework assignment. There's another one due Monday where we're talking about rational exponents. So recall that square root of x can be written as x to the 1/2. And we talked last time about why. I'm not repeating that because square root of x times square root of x equals x, right? And by the laws of exponents, x to the 1/2 times x to the 1/2 is x to the 1/2 plus 1/2, which is x to the 1, which is x. Well, if this times this equals x, and this times this equals x, then this has to equal this, okay? And we do want to say that x has to be greater than or equal to 0. Well, we couldn't even do the square root, right? Which is not a real number. Cause has an e on the end of it. Okay. So what do we mean? Well, okay. What do we mean by the square root of x cubed? Well, that means we take the square root of x times the square root of x times the square root of x, right? And of course, we could multiply the x by the x by the x, and we get x cubed. So this is actually the same thing as the square root of x cubed, right? So it doesn't matter where we write the cube, or what's inside the radical sign or outside of the radical sign, okay? The cube of the square root of x is the square root of the cube of x. Also, brains misfiring this morning. Not unusual. The cube of the square root of x is, well, of course, the square root of x cubed. X square root of x being the same as x to the 1/2. The cube of the square root of x is the cube of x to the 1/2, right? And by the laws of exponents, that's x to the 1/2 times 3. You're raising a power to the power, that's the law of exponents, which is x to the 3/2. Okay. Ponder that for a minute. So, let's say we want to find 4 to the 3/2. How could we write this? We could write this. It's 4 to the 1/2 cubed, couldn't it? And what's 4 to the 1/2? You show me the whole enough figures. 4 to the 1/2 is the square root of 4, right? And the square root of 4 is 2. And 2 cubed is 8. Makes sense? Okay. Try this one. $25 to the 5 halves. What's 25 to the 5 halves? $25 to the 5 halves is 25 to the 1 half to the 5th, which equals square root of 5 raised to the 5th. So square root of 25 to the 5th, which equals 5 raised to the 5th. Now, so I'm going to have to multiply that out. It's 3,125. I just have to know that. Okay. Fairly easy to calculate. That was 500 power. So, 6 power would be 15,625. After that, I don't know. Okay, that makes sense. Get the idea? And one more thing. What's that? If you know the laws of exponents, it's pretty simple. It's x to the 8/3 to the 9 times y to the 5/6 raised to 9. And that's going to be x to the 9 times 8/3, y to the 9 times 5/6. And of course, 9 times 8/3 is the same as 9 over 3 times 8, which is 3 times 8, so that's 24. And then 9 times 5/6 is 45/6. And of course, you can do prime factorization of 45/6. Or you can just note that 3 goes into 6 and 3 goes into 45, one way or the other. That tells you you have x to the 24 times y to the 15 halves. So the arithmetic is just straightforward arithmetic of fractions. Now, you know, the problem that people don't generally know fractions all that well when they come out of the prerequisite courses. So we've done the principles of fractions, so hopefully you won't have much trouble with this, okay? You're going to have plenty of examples in the open math. Okay, very good.